Okay, it has come to the time where we are now ready to find the exact slope of a tangent at a point. We know what secant lines are, that they're average rates of change across a decent sized distance. And then you saw what tangent lines were, and we could see what a tangent line looked like on a graph. We could find the slope of that line, and that was an approximation. And then we also used this idea in our previous lesson where you were just looking across a very small interval and using that to again calculate slope to approximate the instantaneous rate of change. Okay? We were looking, as I said, across a very small interval. Okay, and what we had used was these really small numbers. So, like it was 0.001, maybe there were 3 zeros, and it was from the point that we were interested in. Now, the interval could be anything, right? So what we're going to do is we're going to say, let's let the interval delta x, the change in x, I'm just going to set that equal to h. And in order for us to actually find the slope, what we can do is we can substitute any number for h as we see fit. It could be 1, it could be 10, or it could be as small as you want. But what's really cool is we can also determine the exact slope of the tangent line without substituting a number at all. Dun, dun, dun. Let me show you how this is going to work, okay? So we're going to start and say, I'm looking to find the slope of my tangent line, m of my tangent. Recall that slope is delta y over delta x. And previously, you were given some kind of range between point A and point B. So the way that you found that is you said, well, what's my function at B? Take away my function at A, all divided by B minus A. But what we have just said is we can actually change what this B value is. The B value is if we were to start at our A, but then we're adding our really small interval, so H, A plus H. Okay? So what this is going to look like now is it's going to look like f of A plus H, take away f of A, all minus A plus H, take away A, which is just H on the denominator. So our function of A plus H, take away our function at A, all divided by H. And now what we actually want to do in order to get this exact is we want to be taking the limit of this. We want to be taking the limit of this whole thing as h gets really, really, really small, as h approaches 0. It's never going to hit 0. That's impossible. We cannot have 0 in the denominator. But we're going to be taking the limit as h gets really, really, really small, as h approaches 0. This is the formula that you are going to use. Okay, this is the long way of doing it. I'm going to be honest with you, but it's important that you understand where it comes from so that when you go into calculus, for example, you're able to do it and appreciate it sort of the quick way that you'll learn in calculus. You're able to appreciate where it comes from. Okay, let's use this formula for a couple of different examples. Determine the slope of the tangent line of the function f of x is equal to negative 3x minus 5 when x is equal to 2. Okay, we're going to start by saying, well, my IROC, and I'm just going to use the formula we just developed. Limit as h approaches 0 of f of a plus h, take away f of a, divided by h. Okay, what is my function here? My function is negative 3x minus 5. So I'm going to swap that in. Negative 3, a plus h minus 5, minus negative 3a minus 5. All divided by h. Okay? We're going to expand this. Okay, I'll have a negative 3a minus 3h, take away 5. Subtracting negative 3a will be adding 3a, and then subtracting negative 5 will be like adding 5, all divided by h. Just bear with me here. Okay. Notice how I have a negative 3a and a positive 3a, so those are going to cancel out. I also have a negative 5 and a positive 5. Those are also going to cancel out. So my simplified function here is negative 3h divided by h. That cancels out. My final answer here is negative 3. My IROC is negative 3. I've gotten rid of the h. H no longer needs to approach 0 because there is no h in my equation. My instantaneous rate of change is negative 3. Okay, and that makes sense. We're looking at a linear function here. Okay, it already looks like a straight line. So of course the instantaneous rate of change is going to match that straight line. Okay, let's do another one with a bit of a higher degree. For the function f of x is equal to x squared minus 2, find the slope of the tangent line at x is equal to 12. I'm going to do the exact same thing. I'm going to start off by saying my instantaneous rate of change is the limit as h approaches 0 of f, and I'm just going to use x this time, x plus h minus f of x divided by h. Limit, h approaches 0. So my function here is x squared minus 2, and I'm just going to sub in x plus h for the x. And then I'm subtracting my original function all over h. I'm going to go ahead and expand here. So if I have an x plus h all squared, that's going to be an x squared plus 2xh plus h squared minus 2. And then I'll also have a negative x squared, so minus x squared, and then a plus 2, subtracting a negative, divided by h. Okay, let's see what things we can cancel out. I've got an x squared and a negative x squared. I've got a negative 2 and a positive 2. That's very promising. So I'm now taking the limit of 2xh plus h squared divided by h. Okay, I can divide out an h from all of these to get rid of my denominator. So now I'm left with 2x plus h. Now what we're doing at this point in time is we're saying, okay, we want h to get as close to 0 as possible. Let's actually just set it equal to 0. Okay, so I'm going to make h equal to 0 at this point in time. Once I do that, I no longer need to write limit as h approaches 0. Okay, for all of these steps beforehand, you had to write. Okay, so before subbing in, you have to keep all of these. Limit as h approaches 0, limit as h approaches 0, limit as h approaches 0. You got to keep all of this until this very moment when you've finally gotten rid of the h in your denominator. Then you substitute in 0, and now we're just looking at the function. Again, the question was the IROC is going to be equal to 2x. And what is x? We're being asked to find the instantaneous rate of change when x is equal to 12. So I'm going to plop that in here. I've run out of room, so I'm going to come over here. 2 times 12 is 24. So our instantaneous rate of change at x is equal to 12 for the function x squared minus 12 is 24. If you were to sketch out this function x squared minus 2 and you were to find the point 12, draw a tangent line, that tangent line would have a slope of 24. okay? So this is a long-winded technique. Remember that you can't do anything as long as h is in the denominator, and once you've gotten rid of it, you've been able to factor it out, you can sub in 0 and then simply solve. Okay, we'll do one last one with a longer question, just so you get the feel of it, okay? The path of a diver follows the function h of t is equal to negative t cubed plus 2, that should be a t, plus 2t plus 5, where h represents the height of the diver in feet and t represents the time elapsed in seconds. Determine the instantaneous rate of change after 1 second. Okay. Previously, I've used the letter h as my sort of like difference, my delta x. Here I'm going to be using a instead because I already have an h in my equation. Okay, so let's go. IROC is h of t plus a minus h of t, all divided by a. So in this case, it's going to be negative t plus a cubed plus 2 times t plus a plus 5. Subtract the original function, negative t cubed plus 2t plus 5, all divided by a. Now I have to expand this. I need to get rid of my exponent there. And I'm going to do that off to the side, actually, because that's going to take up a whole lot of room. Aside. So I have a t plus a cubed. So that's t plus a times t plus a times t plus a. I'm going to expand the 2 into a quadratic, leaving me with t squared plus 2ta plus a squared times t plus a. And now I'm just going to expand, so that'll be a t cubed plus a t squared plus 2t squared a plus 2t a squared plus t a squared plus a cubed. Let's see if I've got any like terms here. So I'll have a t cubed for sure, an a t squared. Oh, that looks like one here as well, just in a different order. So this will be a 3at squared. Okay, so that one's dealt with, this one's dealt with, this one's dealt with. Then I have a 2ta squared and then another ta squared, so that'll be 3ta squared. You know what, I'll write them in the same order. At squared, and then plus a cubed. Okay, this is the stuff that we need. So bring it up here, and all of this has to be negative. Remember, we had a negative out front. We'll have a negative t cubed minus 3at squared minus 3a squared t minus a cubed. That was just this first one here. Now I've got this stuff. Plus 2t plus 2a plus 5. Whew. Take away all that stuff. Negative t cubed plus 2t plus 5. You know what? I actually don't need these brackets, and I'm going to expand this appropriately. Subtracting a negative will be like adding a t cubed minus 2t minus 5 divided by a. Things get messy. Okay, what can we simplify here? I have a negative t cubed and a positive t cubed. I've got a positive 2t, a negative 2t. Positive 5, negative 5. Okay, we're confirming here that every term left over has an a. That means that you've done it right, because we know that we've got to factor that out. Okay, negative 3at squared minus 3a squared t minus a cubed plus 2a, all divided by a. And I've just realized I've forgotten something here. I've forgotten to add that limit, because we want to be taking this as a is approaching 0. So I'm going to add that to every line here as a approaches 0. A approaches 0, A approaches 0, and A approaches 0. Okay, now we're good. Okay, let's factor out that A from all of those terms. So I'm left with a negative 3t squared minus 3at minus a squared plus 2. Okay, and now at this point in time, I'm going to substitute in a is equal to 0. That's going to mean that this term and this term disappear. So I have a negative 3t squared plus 2. And the question asked me to find what the instantaneous rate of change was after 1 second. So I'm going to sub in 1 for t. Negative 3 times 1 squared is just going to be 1. So negative 3 times 1 is negative 3, plus 2 is negative 1. So the instantaneous rate of change at 1 second is negative 1. That is what your slope is for the tangent line on this function at 1 second. Okay? Lots of math here, not super challenging, just a bit of a pattern to get used to. Lots of stuff to mentally keep track of as well. Okay? Great work, everybody.